This was about a couple years ago, a year and a half ago, and I was really starting to have some problems with my heart beating irregularly. Specifically, it would beat for a while and then just stop or skip a beat and then start beating again. Um, and it was bothering me, but particularly one night, I woke up late at night, and sometimes when you're middle of the night, your brain plays games with you, and I just was obsessed that I was pretty sure it was mostly happening in my left wrist and not my right wrist, that it was skipping a lot more quickly in my left than it was in my right, or more often, more frequently. My heart was, and I thought, oh, maybe there's some kind of blockage in my left arm. And so I was panicking for like an hour or so, this anxiety. And then I thought, you know what? I'm going to run a statistical test. I'm going to do a two samples test. So that's what I did. I collected data. So I would go on the left, I would count how many beats until it skipped a beat. So it went 5 beats, then skipped one, then 12, then skipped one, 6. And then after a while, I would come back and do the right hand. So I'd kind of go back and forth, just counting how many beats does it go until it skips a beat. And I recorded all that data. And my question was, are the pulses different in my two wrists? I could have done one-tailed. I could have said, is my pulse skipping more frequently in my left wrist? But I just wanted to test it either direction. Is there any difference in how frequently or how many beats I get until I get a skip in my two wrists? So the null hypothesis here is that there is no difference, that if I would take the average number of heartbeats until a skip in my left minus the average number of heartbeats in my right until a skip, that it would be 0, because on average, the two will go the same amount of beats before they hit a skip. The alternative here is two-tailed. It would say that if I would subtract those two, they're not equal to 0. In other words, either the left might be going longer before a skip, or the right might be going longer before a skip. So it is a two-tailed test there. All of that's the same as when we had one sample. There's really nothing different here except we have two data sets. So now we have two different sample means, 12.59 on average before a skip in my left and 12.85 before a skip in my right. So here we can see that my left was skipping a little more often than my right, but just by a bit. So the question is that due to random chance? If so, then maybe the null hypothesis is true. Or is it due to one of my heartbeats, one of my wrists having a more irregular heartbeat, in which case that's the alternative hypothesis. So the null hypothesis is just randomness. I happen to get a little worse of a sample here in the left than I did in the right. The alternative is that there's actually something going on. So I collect this. You don't need to worry about quite all this data here, but it gets us down to the p-value again. So the p-value here would be saying, if the null hypothesis is true, if it is the case that the heartbeat is the same in the two wrists, then what's the chance that I would get sample means this far apart from each other just by random chance alone? And here it tells me that is 92% chance, which means this wouldn't be rare at all. So same idea, the p-value would need to be below the alpha level of significance in order to reject the null, but we're nowhere close to that, so we would fail to reject the null. In other words, we weren't able to find evidence that there's any difference between my wrists. And that's statistical significance. Practical significance is basically there's really nothing going on here. And here, my confidence interval, I'm pretty sure that the average number of skips, or average number of beats before a skip, is somewhere between 5.76 more in my, I'd have to think about this here if I did which one was minus the other, E9 minus F9. So my left minus my right, so that the right had actually more, or that the left had more beats per minute, up to 5.23 more beats until it hit a